Hi everyone, I think we should be live. You can let me know if you can hear me.
Hi everyone, I think we should be live. Can let me know if you...
Okay, cool. So let's get started. So this was the question of today. Quite honestly, yes, it was a medium question, but it required some amount of thinking. Uh, so so I would grade it as a good question. Okay. Yeah, so let's read it. It says that we are given an array of positive integers as input. That is what we have here, okay, this vector of integers. Now we have to perform some operations, possibly none, possibly no operations on this array so that it satisfies following conditions. Okay, now what are the conditions? So basically, see, we want to do some operations on this array so that the resultant array has certain properties. Okay, now what those properties should be? The first property is that the value of the first element in array must be 1. So after all those operations are done, the first element must be 1. Okay. The next thing is that the absolute difference between any two adjacent elements must be less than or equal to 1. Okay. So I believe you understand the meaning of adjacent elements. Adjacent means left and right, which is index I and index I plus 1, or index I and index I minus 1. So what we want is that the absolute difference between the adjacent elements must be less than or equal to 1, which means, let's say we have an array, and let's say there is some element over here called as 7. Okay, if there is an element over here 7, then can you tell me how many choices do we have for an element towards the left? I mean, how many possible values uh, can be there in the left element, and what those possible values are? Yeah, so if you look at it, I can have a 6, but I can also have a 7, right? And can I have an 8? Yes, because I want to have an element whose absolute difference with this is smaller than or equal to 0. So if it can be 0, that means I can have 7 also. And if it can be 1, that means I can have 7 minus 1, which is 6. And I can also have 7 plus 1, which is 8, because the absolute difference with both of them is 1 only, right? Okay, now this property should be true for all the adjacent pairs. So the element towards the left side of 8 should also be either 8, or it should be 8 minus 1 or 8 plus 1. Similarly, the element towards the right side of 7 can be 7 or 7 minus 1 or 7 plus 1. Okay, so these are the properties that we want in the resultant array. So what are the properties? The first element should strictly be 1. You have no other option. And the second property is this, which we just discussed. Now, there are two types of operations that can be performed. The first operation is we can decrease the value of any element of array to a smaller positive integer. So see, this is a very important point. If there is an element in the array, let's say the element is 7, then you can pick this element and you can decrease. You cannot increase. It's to be kept in mind. You cannot increase the value of any element. So for example, I can't convert this 7 into 8 or 9 or anything, but I can definitely decrease it into a smaller positive integer. So I can make it equal to 6 or 5 or 4 or 1 or 3, anything which is smaller than 7. So this is the first kind of operation, that pick a random element and change its value to anything which is smaller than that. Okay, cool. The second thing is that you can rearrange the elements of array in any order. So if this is the array, I can literally rearrange it howsoever I want. So you can create any permutation of it. Okay, now the question. The question is, we have to return the maximum possible value of an element after performing these operations to satisfy the conditions. So it means you will be given an array, and once you have been given this array, you have to convert it into an array which obeys these two rules. The first element is 1 and the absolute difference between adjacent values is smaller than equal to 1. After doing that, what we want is that we want to find that what is the maximum possible value that this array can have, right? So for example, if you look at this array, how many operations would you want to do? Tell me that first. How many operations are required to convert it into an array with the desired property? So if I take it and after that I simply arrange it in ascending order. If I simply arrange it in ascending order, I'll get 1 1 2 2 2, right? In this particular case, the first element is 1, so the first rule has already been obeyed. Now can you quickly check whether the second rule is already being obeyed or not? The second rule here is already being obeyed because for each pair of elements that you consider, you can clearly see that the absolute difference is smaller than or equal to 1. Okay, but question wants us to find that what is the maximum possible value that we can get, right? And if we want to find that out, let me ask you one simple question. Can we change the first element? No, the first element has to be strictly 1. Now if you look at the second element, it's a sorted array, right? If you look at the second element, it is 1. Would you want to change it to something smaller than 1? The answer is no, because you can't, if you change it to anything smaller than 1, that is of no use to you. You want to maximize the possible value, and also if you change it to something smaller than 1, it is going to be 0, but only positive integers are allowed, right? So what we can do is we can let it remain as it is. We can not increase its value. Can we increase its value? Do you have an operation that allows you to increase the value of an element? The answer is no. You can just decrease. So the only option you have is to leave it as it is, right? Now you move on to the next element and you find that, hey, the absolute difference with this is well within the range. Now would you want to change it to something? Would you want to decrease it? No, because yes, you can decrease it to 1, but that is not going to offer you any benefit, right? And can you increase it to some value? No, you can't increase. Now you go to 2, you check the absolute difference. Is the absolute difference well within range? Yes, it is. Would you want to change it? You can just decrease it, but you would not want to decrease it. There is no use of it. Similarly here also. So it basically means that the maximum possible value that we can get out from here is 2, and hence the answer should be 2 only. So does this point make sense? How many of you understand that how 2 is the answer for this particular input? Right? Okay. If you take any other example, let's say this one. Okay, let's say you have not looked at the answer. Can you tell me what will be the answer for this case? In fact, if I ask you, if you have an array of size n, let's say you have an array of size n, what is the maximum value of answer that you can get? The maximum value of the answer that you can get is n, because in the worst case what you can do is you can change the first element to 1, second element to 2, third element to 3, 4, 5, and the last element to n. So the maximum possible value of your answer can be n, provided you have n elements, right? Your maximum possible value cannot be n plus 1 or n plus 2 or anything more, because if you're doing that, that means you are missing an element. And if you are missing an element, that means the adjacent difference rule is not being obeyed. So in this case what I can do is I can probably first rearrange it into ascending order. Thereby we get something like this, 100,000, and after that we can change this element to 2, which we can, right? and after that we can change this element to 3. Why I could change? Because the value over here was greater and I was allowed to decrease, so I was able to decrease it. Similarly, the value over here was 1000 and I could well decrease it to 3. I could not change it to something like 5, because if I change it to 5, the absolute difference rule would be dishonored. Okay, I believe now everyone is clear with the question. You guys can just type in a yes if now the question makes sense to all, because I encountered a lot of people who told me that they were unable to understand what the question was really expecting. Okay, great then. So then how to go about it? Let me ask you a very simple question. Let's say you already have an array which honors this second rule, which says that the absolute difference should be smaller than equal to 1. Now, if I arrange it in ascending order, will that ascending order also honor that rule? Can I say that? Yes or no? The answer is yes. And why the answer is yes? Common sense. See, the reason is, let's say there was some array. It contained some elements inside it. I don't know what. And those elements honored the absolute difference wala rule. Okay. Now, when you went ahead and sorted it, and after sorting, you got a permutation of it. Now, tell me one thing. Is it possible that in this array you have an element 7? You have an element 7, but you do not have an element which is 6. Or let me take it in different manner. Let's say you have an element 7 and after 7 you directly have 9. Is it possible? The answer is no. It is not possible. Why it is not possible? Because if you have 7, if you have 9, then it is guaranteed that, let's say if there was a 9 over here, before that towards its left there must have been an 8, or towards its right there must have been an 8. Correct? If that was not the case, if let's say you just had a 7 towards the right and another 9 towards the left, then here the absolute difference rule is obeyed, but here the absolute difference rule is not at all obeyed. Correct? So it means that there must have been an 8 towards its right. So it means that if we have an element called as x, then x plus 2 cannot exist if x plus 1 is not there, right? And I think with this clarity, I can say that if we arrange it in ascending order, then that ascending order would also follow the absolute value rule. You can take any other example and you can check that out. Let's say you take 1, 2, and then let's say you have 1, and then again 2, then you have 3, then you have 4, and then again you have 3, again you have 4. If you were to arrange it in ascending order, it is guaranteed that that ascending order would also have this particular rule, because you can see that if you have an element x which is 2 and you have an element x plus 2 which is 4, then x plus 1 is also there, so that will not be skipped. This is a very important point to understand. Is it making sense that the ascending order will also hold this property if the original array had already held this property? It's important to understand this point. Can we count the number of unique elements in array? What's the logic behind that? That's the important thing. But yeah, I'm asking this question again. Does this point make sense that if an array holds this property, then its ascending order, its ascending permutation will also hold this property? Yeah? Okay. So you know what I'm going to do is I'm going to first arrange my input in ascending order. Because we all know that arranging it in ascending order, that is the first operation that we will do. And you know, if at all the original array had that property, then that is going to get reflected in the new array also, right? So that's not much of a big deal. Now, why we are arranging it in ascending order? We are arranging it in ascending order because that will help us change the elements correctly. Because if you have a random array, you will have to find out what is the smallest element. If you sort, you know that the smallest element is array of 0. Now, if array of 0 is not 1, you have to make it equal to 1, because that is the requirement of the question. The first element should be 1. Now make it equal to 1, and after that we have initialized a value result which is 1, because the largest element so far we have seen is array 0, which is 1. And now, as I told you, one by one we start from index 1, and we check the difference between current and the previous element. And if that difference is greater than 1, what should we do? What should we do? Just think about that. So let's say you ended up getting an array where you have 1 comma 5. It's in ascending order. 5 obviously is not having an absolute difference within limit with this 1. So what would you want to do? Do you want to leave this 5 as it is? No, it would be a stupid thing to do so. So you'd want to change it. Now, what is it that you would want to change it into? You have three options. You can either make it 1 minus 1 or 1 plus 1. The better choice is to make it 1 plus 1, which is 2. And I'll tell you why. The reason behind that is that this element was greater than that. And moreover, this array is in ascending order. So whatever your next element will be, that will be even greater, right? So that will be either greater than 5, or that would be equal to 5. So let's say instead of 5 it was 3, right? And let's say after this 3 again you had a 3 here. Now in this case, if you change this 3 to 1, then that's not a good choice. Because if you do that, in that case you will have to probably do a change here again, because if this is 1, this is 3, that's not the allowed difference, limit. But if you rather change it into the highest possible value, which is 2, then the chances of having absolute difference within the range is greater. So what we will do is, instead of changing this element to minus 1 of this or equal to this, I will change it into plus 1 of this. Because if I change it into plus 1 of this, what will happen as a consequence of that is that I'll not have to reduce the next element that I have. Otherwise I'll have to take that call of reducing that also. And if you go on reducing the elements, the maximum answer that you can have, that will not be the most optimal one. Does that make sense? How many of you understand this point? Yeah, so that being the reason, what we are going to do is, if we find that the difference is beyond the limit, we are going to change our current element to previous element plus 1. We could also have changed it to the previous element itself, or previous element minus 1, but we have decided to do a plus 1 here because that is the most optimal thing. And it's like a greedy choice, I would say. Greedy algorithms. And why this greed is justified, we just understood. Because the elements that are going to come are going to be greater only because you sorted the array, right? And now this is just a one-liner where you are checking if your current element is greater than the result. You're just updating the result, and then finally you are returning the result. So that's it. So if you look at it, I just had to sort the array, which took us n log n time. And this entire loop anyways works in order of n time. So this is n log n. This is order of n. Overall the complexity is n log n, and that's what you have, right? Okay, great. So that's it. That was all about this question. It was not any standard question or something, but it certainly was something which required you to think. Now, a lot of people got correct answer for this, but when asked, they might not be able to justify these greeds so properly. And now it is very important to explain the correctness of whatever you have done, why you have done, right? Here we understand why we have chosen to do something like this. We also understood why we sorted the array. We sorted the array because we all know that nothing is going to change. If the original array had that property, the sorted array will also have that property. And sorting the array ensures that we are able to pick and change the elements much more comfortably. As simple as that. Can you solve n? You mean to say, can you solve in order n? Do you have a solution of order n? Anyone who has an order n based solution here? Without using extra space? I thought of one. Did you submit it? Where it uses space. So you might be using some hash map or something like that to store the elements, right? Okay. Yeah, so what's the solution? What's the order n solution? Anyone who has got an order n solution? We can discuss it if you have any. Count sort. What is the range of elements? Oh, the range of element is in between 1 to 10 power 9. Did you see that? What is the complexity of count sort? Is count sort always order n? Is it always linear? Those of you who know, who have studied count sort, can answer that. Is it always linear time, or does the time complexity depend upon the variance of elements? It depends upon that, right? So I'm not sure how you're willing to use count sort. Cannot think about edge cases. Submit it, no? Submit it once, and after submitting, what you can do is you can comment your logic in the chat below it. I can take a look at it, and then probably I can suggest whether that's right or wrong. Yeah. So if you have any solution which you feel can work in order n time, always order n time, then comment it and we can discuss more about it. Yeah. Cool then. So let's do that there. I think that's all for today. I don't have anything else to talk about in this question. Let's probably meet again the next day and discuss the question. Yeah. Okay.